According to the National Electrical Code, specifically Section 300.3, feeder cables must be run in the same raceway. This requirement is in place to ensure proper electrical characteristics and safety within the electrical system. When multiple cables are used for a single feeder circuit, they must be installed together in the same conduit or raceway, whether it's made of opco or ENT, ensuring that the impedance and inductive reactance are balanced. This balanced configuration is essential for minimizing voltage drop and preventing overheating due to circulating currents. If the cables are not run in the same raceway, the magnetic fields produced by the current in each cable can induce voltages in nearby metallic objects, potentially causing eddy currents, heat, and even fire hazards. The code mandates this installation practice to mitigate these risks. Furthermore, running feeder cables in the same raceway ensures that they experience similar environmental conditions such as temperature and moisture, which can affect the insulation and overall performance of the cables. This uniformity helps maintain the integrity and longevity of the electrical system. It also simplifies maintenance and troubleshooting, as all conductors of the same circuit are located in one place. When installing feeder cables, it's crucial to select the appropriate size and type of raceway to accommodate all conductors without overcrowding. The National Electrical Code provides guidelines for conduit fill, specifying the maximum percentage of the raceway's cross-sectional area that can be occupied by conductors. This ensures adequate space for heat dissipation and ease of installation. Additionally, proper grounding and bonding techniques must be employed to minimize the risk of electrical shock and ensure the safety of personnel working on the system. The grounding conductor should be run with the feeder conductors in the same raceway to provide a low impedance path for fault currents. It's important to consult the latest edition of the National Electrical Code and any local amendments to ensure full compliance with all applicable regulations. Failure to adhere to these requirements can result in code violations, safety hazards, and potential liability issues. Therefore, it is important for electricians and electrical contractors to understand and follow the requirements of NEC 300.3 when installing feeder cables. This includes ensuring that all conductors of the same circuit are run in the same raceway, selecting the appropriate size and type of raceway, and implementing proper grounding and bonding techniques. Following these guidelines will help ensure the safety and reliability of the electrical system. To further clarify the requirements of NEC 300.3, let's consider a scenario where a feeder circuit consists of two multi-core cables. These cables supply power from a distribution panel to a remote load, such as a motor or a sub-panel. According to NEC 300.3, both multi-core cables must be installed in the same raceway. This means that if you are using two conduits, both conduits must contain conductors from the same feeder circuit. You cannot run one multi-core cable in one conduit and the other multi-core cable in a separate conduit. This requirement applies regardless of whether the conduits are made of opco or ENT. The purpose of this requirement is to ensure that the magnetic fields produced by the current in each conductor of the circuit cancel each other out, minimizing the impedance and inductive reactance of the circuit. This is particularly important for larger conductors and longer runs, where the effects of impedance and inductive reactance can be more pronounced. By running all conductors of the same circuit in the same raceway, you can reduce voltage drop, improve power quality, and prevent overheating. In addition to the general requirement of NEC 300.3, there are other related code sections that may apply to your feeder cable installation. For example, NEC 300.3 provides guidelines for ampacity ratings of conductors, while NEC 300.3 provides tables for determining the allowable ampacities of insulated conductors. It's important to consult these code sections to ensure that your conductors are properly sized to the load they will be serving. Furthermore, NEC 300.3 provides requirements for box fill calculations, which determine the maximum number of conductors that can be installed in a junction box or conduit body. It's important to perform these calculations to ensure that your boxes and conduit bodies are not overcrowded. In addition to these specific code sections, there are also general requirements for electrical installations that must be followed. For example, NEC 110.3 provides general requirements for equipment, including requirements for listing and labeling. NEC 110.12 provides requirements for workmanship, including requirements for neat and workmanlike manner. NEC 250 provides requirements for grounding and bonding, including requirements for equipment grounding conductors and bonding jumpers. By following all applicable code requirements, you can ensure that your feeder cable installation is safe, reliable, and code compliant. It is always recommended to consult with a qualified electrical inspector or engineer if you have any questions or concerns about the code requirements. Remember, the National Electrical Code is a comprehensive set of rules and regulations that are designed to protect people and property from electrical hazards. By understanding and following the code, you can help ensure the safety and reliability of electrical systems. Therefore, it is very important to run feeder cables in the same raceway according to NEC 300.3. This is a critical requirement for ensuring the safety and performance of electrical systems. Let's delve deeper into the practical implications of NEC 300.3 and how it affects real-world electrical installations. Consider a scenario where a large commercial building requires a new feeder circuit to supply power to a bank of electric vehicle charging stations. The engineer designs the circuit using two sets of three-phase conductors, each set bundled into a multi-core cable. According to NEC 300.3, both multi-core cables must be installed within the same raceway, whether it's rigid metal conduit, intermediate metal conduit, or even a non-metallic conduit like PVC. Now let's explore why this requirement is so important. Firstly, running the conductors together minimizes inductive reactance. When alternating current flows through a conductor, it creates a magnetic field around it. This magnetic field can induce a voltage in nearby conductors, a phenomenon known as inductive reactance. The inductive reactance increases with the distance between the conductors. By running all the conductors of the same circuit together in the same raceway, the magnetic fields tend to cancel each other out, reducing the overall inductive reactance of the circuit. This is particularly important for long feeder runs, where inductive reactance can cause significant voltage drop and reduce the efficiency of the electrical system. Secondly, it ensures balanced impedance. Impedance is the total opposition to current flow in an alternating current circuit, and it consists of both resistance and reactance. If the conductors of a feeder circuit are not run together, the impedance of each conductor may be different. This can lead to unbalanced currents in the circuit, which can cause overheating and equipment damage. By running all the conductors of the same circuit together, the impedance of each conductor is more likely to be balanced, ensuring that the current is evenly distributed throughout the circuit. Thirdly, it simplifies fault current protection. In the event of a ground fault or short circuit, it's essential that the protective devices, such as circuit breakers or fuses, trip quickly to prevent damage to equipment and injury to personnel. When all the conductors of the same circuit are run together in the same raceway, the fault current path is more clearly defined, making it easier for the protective devices to detect and interrupt the fault current. If the conductors are run separately, the fault current path may be less predictable, which can delay the tripping of the protective devices and increase the risk of damage or injury. Now, let's address some common questions that electricians and electrical contractors often have about NEC 300.3. Firstly, does this requirement apply to both new installations and existing installations? Yes, NEC 300.3 applies to both new installations and any modifications or alterations to existing installations. If you are adding a new feeder circuit or modifying an existing one, you must comply with the requirements of NEC 300.3. Secondly, what if it is not possible to run all the conductors in the same raceway due to physical constraints? In some cases, it may be physically impossible to run all the conductors of the same circuit in the same raceway due to space limitations or other constraints. In these situations, you may be able to obtain a variance from the local electrical inspector. However, you will need to demonstrate that you have taken all reasonable steps to comply with the code and that the alternative installation method provides an equivalent level of safety. Thirdly, does this requirement apply to control circuits as well as power circuits? Yes, NEC 300.3 applies to control circuits as well as power circuits. While the consequences of not complying with NEC 300.3 may be less severe for control circuits, it is still important to follow the code to ensure the proper functioning of the control system. To summarize, NEC 300.3 is a critical requirement for ensuring the safety and performance of electrical systems. It requires that all conductors of the same circuit be run together in the same raceway. This minimizes inductive reactance, ensures balanced impedance, and simplifies fault current protection. By following the requirements of NEC 300.3, electricians and electrical contractors can help ensure that electrical installations are safe, reliable, and code compliant. The importance of adhering to NEC 300.3 extends beyond mere compliance. It's about ensuring the longevity and efficiency of electrical systems. Let's delve into some additional scenarios to illustrate this point further. Imagine a large data center relying on multiple feeder circuits to power its server racks. Each server rack is a critical component, and any downtime can result in significant financial losses. By adhering to NEC 300.3 and running all conductors of each feeder circuit within the same raceway, the data center operators minimize the risk of voltage imbalances, harmonic distortion, and other power quality issues that can negatively impact the performance and reliability of the servers. Furthermore, consider a manufacturing plant with numerous motors driving various pieces of equipment. These motors are often controlled by variable frequency drives, which can generate harmonic currents that can cause overheating and damage to electrical equipment. By running all conductors of the motor feeder circuits within the same raceway, the manufacturing plant operators can minimize the effects of harmonic currents and ensure the reliable operation of the motors. In addition to these specific examples, NEC 300.3 also plays a role in minimizing electromagnetic interference. Electromagnetic interference can disrupt the operation of sensitive electronic equipment, such as medical devices and communication systems. By running all conductors of a circuit within the same raceway, the electromagnetic fields generated by the conductors are contained within the raceway, reducing the risk of interference with nearby equipment. It's also important to note that NEC 300.3 is not the only code section that addresses the installation of feeder cables. Other relevant code sections include NEC 300.10.15, which provides guidelines for ampacity ratings of conductors, NEC 300.10.16, which provides tables for determining the allowable ampacities of insulated conductors, NEC 314.16, which provides requirements for box fill calculations, and NEC 250, which provides requirements for grounding and bonding. When installing feeder cables, it's important to consult all applicable code sections to ensure that the installation is safe, reliable, and code compliant. In conclusion, NEC 300.3 is a fundamental requirement for the safe and efficient operation of electrical systems. By running all conductors of the same circuit within the same raceway, electricians and electrical contractors can minimize inductive reactance, ensure balanced impedance, simplify fault current protection, and reduce the risk of electromagnetic interference. By adhering to NEC 300.3 and other relevant code sections, they can help ensure that electrical installations are safe, reliable, and code compliant, protecting people and property from electrical hazards. Let's further explore how NEC 300.3 contributes to the overall safety and reliability of electrical systems, specifically focusing on real-world scenarios and potential hazards. Consider a large hospital where uninterrupted power supply is critical for life-saving medical equipment. The hospital relies on multiple feeder circuits to power operating rooms, intensive care units, and other critical areas. If the feeder conductors are not run in the same raceway, the risk of voltage imbalances increases significantly. These imbalances can lead to equipment malfunction, inaccurate readings from medical devices, and even power outages, jeopardizing patient safety. By adhering to NEC 300.3 and ensuring that all conductors of each feeder circuit are installed within the same raceway, the hospital minimizes the risk of voltage imbalances and ensures a stable and reliable power supply for its critical medical equipment. Another scenario involves a high-rise office building with numerous tenants and complex electrical systems. If the feeder conductors are not properly installed according to NEC 300.3, the risk of overheating and fire increases. When conductors are run separately, the magnetic fields surrounding them can induce eddy currents in nearby metallic objects such as conduit, metal studs, and building structures. These eddy currents can generate heat, which can lead to insulation breakdown, short circuits, and even fires. By running all conductors of the same circuit within the same raceway, the electromagnetic fields are effectively contained, minimizing the risk of eddy currents and overheating. Now, let's consider the practical challenges that electricians and electrical contractors may face when complying with NEC 300.3. Firstly, space limitations can be a significant obstacle, especially in existing buildings where raceways may be already crowded. In these situations, it's important to carefully plan the installation and use the appropriate size and type of raceway to accommodate all conductors without exceeding the full capacity. Secondly, the complexity of the electrical system can make it difficult to identify all the conductors that belong to the same circuit. It's important to carefully trace the conductors back to their source and ensure that all conductors of the same circuit are run together in the same raceway. Thirdly, coordination with other trades, such as mechanical and plumbing contractors, can be challenging. It's important to communicate effectively with other trades to ensure that the electrical raceways are installed in a way that does not interfere with their work and vice versa. To overcome these challenges, it's essential to have a thorough understanding of NEC 300.3 and other relevant code sections, as well as strong planning and coordination skills. It's also important to use high-quality materials and follow best practices for electrical installations. In addition to these practical considerations, it's important to remember that NEC 300.3 is not just about compliance, it's about promoting a culture of safety and excellence in the electrical industry. By adhering to the code and following best practices, electricians and electrical contractors can demonstrate their commitment to safety and quality, building trust with their clients and ensuring the long-term success of their businesses. In summary, NEC 300.3 is a critical requirement for ensuring the safety, reliability, and efficiency of electrical systems. By running all conductors of the same circuit within the same raceway, electricians and electrical contractors can minimize voltage imbalances, prevent overheating, and reduce the risk of electromagnetic interference. By understanding the code, overcoming practical challenges, and promoting a culture of safety, they can help ensure that electrical installations are safe, reliable, and code compliant, protecting people and property from electrical hazards.